Now we're going to solve some rational inequalities. Now, a rational inequality has fractions in it, and instead of an equal sign like an equation, it has an inequality sign, either greater than or less than, or maybe it's greater than or equal to, or less than or equal to. In this case, we have x minus 2 divided by x plus 3 is greater than 0. And we're going to follow the 8-step method for solving a rational inequality. Step 1, we're going to get everything on one side and the other side, on the left side, everything on the left side, the other side 0. Well, that's done. So we can move to step 2, the important step, where we're going to factor the top and the bottom of the single fraction on the left. It's already in its factored form. We don't have to do anything to it because there's no factoring to be done. We're just going to make a comment here that when we have this factor divided by this factor greater than 0, what we're saying is that the entire fraction is positive. To be greater than 0 means to be positive. Okay, and we're not going to forget that. That's why we have put a sunburst around step 2. We're going to come back to it later when we get down to step 7. Okay, step 3 says to set each of the factors in the numerator and each of the factors in the denominator equal to 0 and solve. These are going to give us critical numbers with which we're going to partition or break up a number line. So we got x equals 2 and x equals negative 3. Now steps 4, 5, and 6 involve taking the fraction in step 2, x minus 2 over x plus 3, and finding the sign on the number line for the fraction in the regions that are created by partitioning the number line with the negative 3 and the 2 that we found in the previous step. So here's an x-axis. We've busted it up into 3 pieces, separating it by negative 3 and 2. Now look what we did. Let me just stop this for a second. This first region includes x values on the x number line that are smaller than negative 3 because we're looking at the region to the left of negative 3. Now you can choose any value smaller than negative 3. And to make it easy on yourself, since you can choose any value smaller than negative 3, I'm going to choose x equals negative 100, let's say. Now I'm going to make a sign graph above the number line, a sign graph where I just put the sign positive or negative of each of the factors in the fraction. So it's easier than just putting a number. Just put the sign. I'm only interested in the sign. So I'm letting x equal negative 100 for this region to the left of negative 3 on the number line. And on the top of the fraction where I have x minus 2, I'm saying x is going to be negative 100, so it's negative 100 minus 2. Obviously, negative 100 minus 2 is a negative number. It happens to be negative 102, but I don't care. I just care that it's negative. So I put a negative sign on the top, and then I quickly look at the bottom, and I let x equal negative 100. That's negative 100 plus 3. That's obviously going to be a negative value. So my fraction is negative over a negative. Now a negative over a negative gives you a positive, so I put the arrow pointing down and say, I'm saying that for x values to the left of negative 3, in other words, for x values smaller than negative 3, the entire fraction will have a positive sign on it. See how we did that? Now we're going to go to the region between x equals negative 3 and x equals 2. And we're going to choose an x value that lives between negative 3 and positive 2. The easiest one in that region would be x, let's say x equals 0. You can choose any value in between negative 3 and 2. I choose 0. I'm going to pretend that x equals 0 in the fraction, and I'm going to figure out what the sign, positive or negative, is on the top and on the bottom. When x is equal to 0, the top is 0 minus 2, which is negative. When x is equal to 0, the bottom is 0 plus 3, which is positive. And in the entire fraction, negative divided by a positive is a negative. Now let's go to the last region. In the last region, we're looking at x values that are greater than 2. You can choose any value of x greater than 2 as a test point. I'm going to choose x equals 100 because I can come up with a sign really quickly with a large positive number. Let x equal 100, then the top of my fraction becomes 100 minus 2. That's obviously going to be positive. Divided by the bottom, 100 plus 3, which is also going to be positive. And then a fraction that has a positive on the top and a positive on the bottom together gives me a positive fraction. So what I have at the bottom in the circles in each of the regions is the sign of the fraction in each region of x values. Positive, then negative, then positive. Now we're ready to go to step 7, reminding us what happened in step 2. In step 2, it said that the fraction, the entire fraction that we're working with, has to be equal to a positive. That means we're only going to shade the regions in this graph, x values, for which the product, the entire fraction, is positive. And you'll see where we shaded it. We shaded the region for the values of x that are smaller than negative 3 and for the values of x that are greater than 2, because those are the regions where the x values gave us the positive sign on the entire fraction in those two regions. Now the middle region we'll not shade because the x values in that region between negative 3 and 2 gave us a negative result for the entire fraction. And as step 2 says, we're only interested in the positive result in this example. And then finally step 8, that's where we consider the endpoints. Our original inequality had no equal portion in it, only the greater than. That means we exclude endpoints. We're not going to include the endpoints. We're putting round brackets on the endpoints. And then we make our conclusion. We conclude that the solution to this inequality is the open interval from negative infinity to negative 3 open, union together with the open interval from 2 to infinity. And that's the result by looking at the graph. We decided which regions to shade, and we also decided whether or not to include or exclude the endpoints because there was no equal portion in the original inequality, so there would be no equal portion on the endpoints. We would not put equals, we would put open intervals and not include the endpoints.